Hello, good day. Today I'm going to explain about HSRP, Hot Standby Router Protocol concepts using Wireshark. I have already configured the topology in GNS3. You can have a look at over here. Uh, my primary focus will be over this side. Why? HSRP is a redundancy protocol. Let me explain what does it mean. For this PC, we can have only one default gateway, either 1.3 or 1.4. Even though we are having two physical hardware devices to route to another network, we can only configure one default gateway, right? Think a scenario, my default gateway is 1.3. Suppose this router goes down, even though you are having a redundancy hardware, it still will not send a packet automatically to 1.4. Manually, we need to change. So in order to avoid that scenario, we can use HSRP protocol. So I have already configured the IP address for this device and this interface and this interfaces. And here I am using a L2 switch, not an L3 switch. So I will be showing you how to configure HSRP over R1, and I will replicate the same in router 2. So let me go through the configuration in R1 router. So show IP interface brief. So I'm going to FA0/1. Let's show standby all. We don't have anything. Conf t. Then we need to go to the interface. If you want to configure HSRP, we need to go over the interface. So before I'm going to configure, let me tell you what I'm going to configure. We are going to configure the virtual IP. That means 192.168.1.1. Virtual IP will have a virtual MAC address. So this PC will be having a default gateway as 1.1. That means this device will send a packet to 1.1. So when it is sending to the virtual IP 1.1, either the frames will go from this broadcast domain, either the frame will go to this interface or this interface, whichever is active. So let me show you how to configure HSRP interface FA0/0 standby. We need to define a group. So in this broadcast domain, we need to configure these two in the same group. So I'm configuring as standby group 10 and virtual IP is 192.168.1.1. Okay, first part is over. Now second part is standby 10 preempt. So what do you mean by preempt? Suppose this router is having higher capacity, or this WAN interface is having a 10 Mbps link, whereas this router is of less capacity, or this WAN interface is of 1 Mbps link. And this router goes down, what will happen? Definitely the packet will travel through this router, and it will reach the destination. Now this interface came up, or this router come back. Definitely you don't want the device to send the traffic over this one. You have a faster link over this one. You want to send over to this router, right? So in order to take an active session, we need to configure as standby 10 preempt. So this will become active once it is goes down. It will once it come back, it will become active. Otherwise what will happen is this router itself will be become active, and all the packets will be sending through this only. So standby 10. And another important factor is we need to configure the priority. Which one you need to be active, which one need to be standby. So by default priority is 10. So here in this case I want this router to be active, so I'm giving priority as 125. Otherwise it will take default value of 100. Now another important factor I want to discuss about is, think a scenario where this WAN interface goes down. This device is not never gonna come to know about this one, but it will be still, or this frames this switch won't become to know about this one. So what happens is frames will be still sending over this one, and packet will drop. So that that doesn't anyone doesn't want to happen that. So to avoid that situation, we need to track this interface. All right, and whenever this interface goes down, if we need to tell to this router that you reduce your priority from 125 to less than that of these guys, maybe 95. maybe 95. If I'm suppose if I'm configure this as a default value of 100, that means priority of this router will become 95, and which is less than this one. That means this router will become active and traffic will pass through this way. So how to configure the track? Standby 10 track track interface FA0/1, and you need to decrement value by 30. 125 minus 30 is 95. All right, that's all. Cool. So let's come and look into our configuration. Standby all. So all right, this interface is down. Why it is down? Show IP interface brief. Okay, protocol itself is down over 1.3. Let me make it up. uh, Interface FA0/0. um, um, no shot. All right, and this changes state has come up. Now show standby all. The state is now in speak. It is sending a hello packets. Okay, and there was no response from anybody else, so it became active. So it is using a virtual IP address of 192.168.1.1, and virtual MAC address is this one. We are using version 1, HSRP version 1. Hold all time is 3 seconds. I'm sorry, hello time is 3 seconds. That means hello packets are sent every 3 seconds, and hold all dead timer is of 10 seconds. All right, then active router is unknown, standby router is unknown, priority is 125. Let's configure R2. I'm going to configure the same as of this one. Only thing is I am going to keep the priority as 100, that is default one. All right, so let me pause it and I will get back to you soon. So I have done R2 configurations. So let me quickly show you what I have done. Interface FA0/0, standby 10, group is 10, both are should be same. IP address is sorry, virtual IP address is 1.1. Preamp time's been configured here as well, and I am tracking this interface as well, and the priorities I'm keeping as a default. So this has been changed from standby. This group or this interface went to this to. Let's look into R1 now. R1 is, see, it has sent the status from standby to active. Now look at the state is active. Okay, and active router is local, that means R1 is local. Standby router is 1.4, that is 1.4 is this one, and priority is default 100, and priority is 125 for our local router. Okay, now let's look at the MAC address. Sorry. Okay, 1.2 and gateway is 1.1. All right, now let's check the ARP table is empty. Let's ping 192.168.1.1. Okay, somebody is responding. Let's look what is the MAC address over here. um, ARP. So it has learned the MAC address or ARP table has been updated of 1.1 is this one, that is a virtual MAC address. Virtual MAC address, did you see here? This is the virtual MAC address. So what has been happening behind the door? Let's look through Wireshark. So 1.3 is our active. 1.3 is active now, and 1.4 is standby. So 1.3 is active, 1.4 is standby. All right, so let's see what's inside. So it is using virtual MAC address, this interface 1.3, and it is using a multicast address of 224.0.0 and port. Look at the port, that means UDP. It is using a UDP. Did you see here? UDP 17, and it is using a protocol port number of 1895. What is inside this one? Hello packets. So hello packet, we have the states. Okay, hello time of 3 seconds. Default is hold on timer is 10 seconds. Priority of this one is 125, group is 10, and virtual IP is this one. Authentication I didn't configure. Yes, in order to have a security, you can configure password for both of this group 10. All right, so now what I want to show is uh, what's happening in the switch. what is the MAC address table inside the switch? Show or show MAC address, enable show MAC address table. So the virtual IP address is binded with GI01 interface. Now what I'm going to do is I'm going to bring down this interface. Okay, now let's make sure this is still working. Okay, I'm going to bring down router 1 conft interface fa0/0. I'm bringing it down, shut. Okay, now let's see, still it's responding. uh, oh, it's not responding. Let me check why it should respond. Okay, so now it is responding now, 1.1. So let's check ARP again. What is ARP? Virtual MAC address. Okay, now let's go to the switch. What's happened with the switch? Show MAC address table. See, the MAC address has been changed to this interface, right? So how does this switch know that this MAC address is now binded over this interface, not over this interface? Let me show you that in Wireshark. So if let me capture the R packet, which will give some idea. So nobody was responding for that. Now see, gracious ARP has been sent over here. So who is sending that? See, this has been sent, gracious has been sent. Who is having, see, from this interface. Once the device is identified that other interface is down, it will send a gracious ARP. So gracious ARP means it's a broadcast packet. See, broadcast packet FFFFF, and source is virtual MAC address of this interface. This interface. That means switch will update its CAM table from the gracious ARP. Then when a packet comes from here, it will switch over to the this interfaces. Is that clear? That's how the switching happens. I believe I have covered pretty everything. I hope you liked the video. If you liked the video, please feel free to write down your comments and questions, and also please subscribe my channel. Thank you.